Good evening, everyone. My name is Venkat Sai Chetan Soleti, and the topic I have chosen for research paper presentation is a content-based image retrieval method based on the Google Cloud Vision API and WordNet. This is the reference of the paper, and this paper is published at Springer International in 2017. These are the contents of the presentation. This includes abstract, introduction, literature review, proposed method, experimental results, and conclusion. Abstract. Content-based image retrieval method analyzes the content of an image and extracts the features to describe images, also called as image annotations. So to get this, machine learning algorithms are normally used, but there are two problems with this, like it is time consuming and there is one more issue like semantic gap between the images in image labeling. So to overcome this problem, Google Cloud Vision API is a solution because it can save much computational time. To resolve the second problem, like the semantic gap, a transformation method is defined for mapping the undefined terms by using WordNet. The experiments are performed and the results shows that it is better than three well-known machine learning algorithms. Introduction. Content-based image retrieval uses low-level image features to retrieve similar images from an image dataset based on image feature similarity. The image annotation is basically divided into two methods, classification-based method and a probabilistic modeling-based method. These methods takes long time and they are expensive. So to address these issues, the paper suggests using the Google Cloud Vision API, which assigns labels to images using deep learning algorithms and pre-trained models. So, by using this, the semantic gaps between the image API labels and the image datasets can be solved by combining the Cloud Vision API and WordNet. Literature review. In the previous researches to overcome the semantic problem, image annotation is used to add text information to images. Image annotation is divided into classification based and probabilistic modeling based methods. Classification based methods extracts low level features from images to train as patterns probabilistic while probabilistic modeling based methods calculate the joint probability between the image content and corresponding annotations. So, both the methods mentioned above have their limitations and they are based on image recognition. So, it is difficult to get accurate results because the images are not with the abstract concepts. So to overcome these issues in this paper, author is using Google Cloud Vision API method to solve the above methods limitations. Proposed method. The label annotation of this figure is done by using Google Cloud Vision API. The label results are returned in JSON format and as you can see in the figure, in the JSON record, the mid description and the score or the message ID, image annotation and the score of the annotation respectively. The score represents the confidence of the annotation. The image annotation with the highest score, that is 98.55% is the polar bear, and the second one is mammal with a score of 95.87%, and the third one is animal with a score of 93.44%. The Cloud Vision API may not return some labels if their score values are too low in some figures. Because if you look at the figure, it can capture at least 10 to 12 labels, but the Cloud Vision API mentions and do the image annotations of the labels only if their score levels are high. So, because of this, for the given figure, the Google Cloud Vision API only labeled three image annotations. So this is the uh, proposed methodology. In this, the Google Cloud Vision API might be capable of extracting annotations from the images, but the need of WordNet came into the picture because human may not use the same term to identify an object. So, to overcome these issues, the WordNet came into the picture where the WordNet can be used to find the synonyms of the same word and which can be used to reduce the semantic gap between the both the labels given by image dataset and Cloud Vision API. So if you look at the figure, we can explain the flow as first the input figure is passed through Google Cloud Vision API, and from there we obtain the labels which contains mid description and score, and then it is compared with the labels given by the image dataset. If they both are identical, then it goes to the output as correct, and if they are not identical, then the comparison is done using WordNet. If they both are equivalent, then it comes to correct. If not, then it results the output as not correct. So this is the code which is used for interfacing WordNet with Google Cloud Vision API. WordNet has a defined set of cognitive synonym sets for nouns, verbs, adjectives, and adverbs. Their synonyms are helpful to match the labels from image dataset and from the Cloud Vision API, and this can be implemented by using the R language. And if you see in the code, a function called checkwords is defined to specify the word from dataset in WordNet and the Google Cloud Image API. Therefore, by using this code and the we are able to match the words of image dataset and the words given by the Vision API. Experimental results. So the experiments are performed using a single dataset called Pascal VOC 2007 image dataset. This dataset consists of 4,952 images and 20 different categories of these images. So the Google Cloud Vision API is tested using this dataset, and the images are tested using two methods. Those are method 1 and method 2. Method 1 represents the testing the images using Google Cloud Vision API, and method 2 represents the images validation using Google Cloud Vision API with WordNet. So, by using the WordNet, we were able to reduce the semantic gap between the words from the image dataset and the words given by the Google Cloud Vision API. So, this is a table which represents the synonyms of the different words by using WordNet. The equivalent names obtained from the WordNet are present in the table, and we found that the terms given by WordNet of chair is not the one we need because the WordNet shows chairman, chairperson, chairwoman, electric chair, and so on. But those synonyms are not correct for the word chair, and the synonym of the motorbike does not include motorcycle, and in addition there are some categories including the dining table, potted plant, sheep, and TV monitor does not yield any synonym. Hence we expect the number of corrects could be improved by WordNet. So by doing this, it will improve the efficiency of the Google Cloud Vision API with WordNet in image recognition. So this table represents the mean average percentage of different words using two methods, method 1 and method 2. The mean average percentage of method 1 and method 2 are 32.1 percentage and 42.4 percentage, indicating the improvement of 10.3 percentage between the two approaches. So the major reason for this is due to the average precision of aeroplane, car, and sofa are all 0% in the method 1, and after we applying the WordNet, They are 78.5 percentage, 77.4 percentage, and 19.1 percentage respectively. So it might be necessary for a researcher or practitioner to apply the WordNet if we want to improve the accuracy. And there are some limitations. If you see in the table, the performances of dining table, motorbike, potted plant, and TV monitor are all still zero even after using the WordNet. So by improving the WordNet accuracy or efficiency, it will help the Google Cloud Vision API to increase its efficiency percentage in image labeling. So the results in the literature, including the different machine learning algorithms, and in the table it represents the mean average percentage of the different machine learning algorithms in image recognition, and all these are tested using the same Pascal VOC 2007 dataset. And from the table we can see that RCNN-FT-FC7BB is the best algorithm among the different algorithms present, and it has an accuracy or mean average percentage of 58.5 percentage. And if you see method 2, that is using the Google Cloud Vision API with WordNet, it has a mean average percentage of 42.4 percentage, which is the second highest, and it is better than three uh, well-known machine learning algorithms like DPM V5, DPM ST, and DPM HSC algorithms. So, conclusion. This paper proposes a comparative study between the effectiveness of Google Cloud Vision API and existing efficient algorithms in image recognition. The proposed method employs WordNet to bridge the semantic gap between the labels generated by Google Cloud Vision API and image dataset. And if you see the experimental results, it reveals that the suggested methodology accomplishes high accuracy even for categories that are not available, and lessens the computational workload as it is a pre-trained model. And looking at these results, it is suggested to use it in industries to deal with their daily routine, which needs an image recognition procedure. And for the future research, we can modify the category name it fit to the labels given by Google Cloud Vision APIs, and we can evaluate the proposed scheme to test more well-known datasets. So, by looking at this paper, it shows the importance of the Google Cloud Vision API, and with WordNet, as it is a pre-trained model, it will reduce the computational effort, and it makes the developers or the people who are using this uh, trained model for image recognition makes their work easy. So this is the end of the presentation, and thank you.